Hello, we are the LyonTech team. We are happy to prepare again the Atom RoboCup challenge. After participating in SSPL and in OPL, we only candidate this year to the Open Platform League. LyonTech is composed of the engineering school CEPE Lyon, its former member, but also inside Real City Lab, where some of us do the research, Palo IT, a digital company, ID IoT Lab, a collaborative maker association, and the University of Lyon. We built our own robot based on a Palm mobile platform. We built it up with a high body holding a 7 degree of freedom custom arm, a tablet, 3D cameras, and a few other sensors. We baptized it Palbator. Let's move on to the scientific contributions, starting with the task orchestrator, illustrated here with a pepper in the RoboCup arena in Montreal. At each step, you can see on the left a description and in the diagram the bounding boxes in orange showing what is called in the global architecture. ROS, Naoki, and web services get along together to link the different distributed features ruled by a global manager. This architecture was developed in order to be run on Naoki-based and ROS-based robots. You can find more information about it in the article referenced below. Please check on the right, in the middle of the architecture, the box called People Detection Learning, which is the object of a new publication on the next slide. This publication received the Best Scientific Paper prize at the RoboCup Symposium. As you can see on the left, it's about tracking people pose, gesture, face, and clothes with a single 2D camera embedded on a robot. On the right, you can see a navigation among movable obstacles with social constraints, published at IROS in 2020. Both of those two publications had already been concretized in the RoboCup trial, as you can see on this slide. On the left, for people feature extraction, and on the right, to clear the path from movable obstacles. Let's see our Palbator robot performing the receptionist scenario. On the right, you can see the robot in its map with its planned path represented by a blue curve. On the left, you can see the object detection on the top and the body pose detection below. Let me describe the behavior. The robot is moving from one room to another in order to reach the home entrance. Somebody on the way is being detected as an obstacle. The robot stops and plans a new trajectory. The robot is now waiting for a guest to enter. Please notice that from now the external camera displayed in the center of the video will be replaced by the output of our people feature extraction. A guest, me actually, is entering in the room and is welcomed by the robot. After a quick interaction, the robot is escorting the guest to the living room, crossing first the kitchen. As you might see, the robot struggles a bit to move through the narrow path. In order to weight the robot, I will open a parenthesis. After the scandal of the baby cup obstacle at the RoboCup in Leipzig in 2016, we added on the robot a few time-of-flight sensors below the main lidar in order to detect small obstacles. Then, on the simulated version, we placed a 3D camera pointing to the floor to implement the Namo. Hopefully, we will try to do the same on the real robot for this year. Finally, the robot has reached the entrance of the living room of our RoboCup arena. From this point, the robot identifies the people already sitting, knowing who is where, with which posture, thanks to our people feature extraction system. Then, coupled with our object detection and the top 3D camera, the robot is able to deduce the place to suggest to the guest. Let's have a look to our robot detecting and picking objects with our custom arm. The arm has a long prismatic joint working as a lifter, followed by 6 rotary joints and a wipers-inspired gripper. Thanks to a 3D camera placed in the middle of the robot arm, we detect and locate the wanted object. Then, the arm performs an invert kinematics to grasp the object and bring it to the right person. By the way, we are looking for an intern to improve our arm and its grasping software management. Please find our job offer on our website and share it with your network. Now take a glance to the Go and Get It scenario captured during the COVID edition of the RoboCup in simulation. The video will be sped up at different speeds throughout the scenario. After crossing the grasping area, the Palbator robot is moving obstacles with the Namo feature, as it was needed in this run to reach the storing shelves. Once in the front of it, the robot identifies, locates, and grasps the requested object to bring it to the correct person. Here is a few other ATOM scenarios we perform with different robots. On the left you can see our Pepper robot adding points to the bar game in the Take Out the Garbage trial in Sydney. On the top right corner, you can see the Toyota HSR robot actually performing the cleanup scenario for the simulated SSPL League in 2021. On the bottom right corner, Pepper is performing a task as a Global Purpose Service robot, commonly called GPSR, here in Montreal in 2018. I let you admire the end of those scenarios, and I take back the microphone in half a minute. We are reaching now the end of this video. If you are from the organization committee, we hope you judge us worthy enough for the competition in Bordeaux. And whoever you are, we hope you enjoy this content. If you want to use our features, you can freely access them on GitHub. Thanks for watching.